All right, in this video, we're going to graph absolute value functions, and we have to learn something called the parent form and the general form. The parent form is kind of easy. I'm going to use f of x, and then I'm going to say equals the absolute value of x. There's another way to write this that isn't with the f of x, which I think I'm going to use for the rest of them just because it's more simple. And so we're going to use y equals the absolute value of x. Now, when you graph this one right here, it's going to make like a V on the graph, and we'll see that in a second. But first, let's go to the general form. The general form is the one that has like all the bells and whistles. So in this case, it's going to be f of x equals a, and then we got the absolute value minus the x value, and then plus the y value. You could also see this written as y equals, and it's the same thing. They just changed f of x to the letter y. Okay, now that you've got this whole thing, this one's actually easier to understand. So we are going to highlight this A. I don't think I want that color. Let's do yellow. That A right there and that A right there. Think of that as your slope. So we're gonna write, that is like your, I'll change it. That is like your slope. And we'll deal with that in another video. We're gonna let that go in this video. We really need to talk about the H and the K. The H and the K combine together to form your vertex. And your vertex is the V point that you graph. So we'll do that when we do the examples. So first, I'm going to put here that this is going to be, you're going to change whatever this symbol is in here, because it's negative. When you graph it, it is going to change. I'm going to mark that in red. So this one you're going to change. And then the one next to the K, this plus sign, you're going to keep that. So it's change, keep. And this will help you out when you do other graphing in math as well. So let's do the first one. Let's say we have, let's change it to blue. Let's say we have y equals the absolute value of x minus 3. Bam. And that's it. That's all they give you. Well, I know that there needs to be a k, so there's an invisible 0 right here. And so when I plot my vertex, it's going to be not negative. We're going to change that. You change it to what? The opposite, which is positive. So my vertex, let's make it pink. Vertex is parentheses positive 3 and 0. So what is the first letter or the first number? It's the x value. And the second number is the y value. That means you got to go find that 3 on the x-axis. 1, 2, 3. And then 0 means we don't go up or down. We stay right on this bold line. And now I'm going to graph it, and I'll graph it in orange. I'm going to put a dot right there at 3. And then this is where it gets interesting. I'm going to go out a little bit. In order to actually make the graph, there's an invisible 1/1 here, or you could just remember it as a straight diagonal line. So we are going to go up 1, right 1, up 1, right 1, up 1, right 1, right there, up another 1, right 1, right there, up another 1, right 1, right there. And that is 1/2 of your V. Because it can't go down, absolute value has to stay positive wherever it tells you to go positive. So it like bounces off and goes this way. So now we're going to go up 1, left 1. It's almost like it reflects like a mirror across the number 3. And then we're going to do it again. Up 1, left 1, up 1, left 1. And then we graph that side. And that is the answer. So kind of weird, but also kind of fun. So let's try another one. Let's try What if I change the 3 and I put the 3 on the outside? So it's y equals the absolute value of x, and then we got plus 3 on the outside. Well, in this case, we know the vertex. We have no number inside with the x, so that's going to be 0. There's our invisible 0. And then the 3 is like the y-intercept, so that's going to go right there. So now we got 0, 3. Well, this is x. That means it's in the middle, and this is y, which means it's on the y-axis. So now I got to go 1, 2, 3. Right there. And I put my point, and let's do it in red. Right there. And now I go up one, right one, up one, right one, up one, right one. Bam, bam, bam. And then I'm going to go up one, left one, up one, left one. So up one, right one, ba-boom. Up one, right one, ba-boom. Up one, right one, ba-boom. That kind of matched up? Nah, it didn't match up. Let me try that again. It should be right there and right there. There we go. And then up one, left one, up one, left one, and up one, left one. And then you graph it. It should be diagonal on both. And you're supposed to put the arrow at the end to show that it goes on forever and ever. Sorry, that did not did not mean to make that a little squiggly. All right, let's try another one. This time, let's do it in green. Let's see if we had both. What if we had something like y equals the absolute value of x plus 2, and then we bring it down 6. Okay, first, what's our vertex? So now our vertex is going to be, don't put plus, it's the opposite, which is negative. So it's -2, comma, and then we keep this, right? Change the first one, keep the second one. So we keep the negative on the 6. So now we got -2, -6. Where's that at? Well, -2 is right here. And -6 is 1, 2, 3, 4, 5, 6 is down here. And then let's do it in red. So -2, -6, it goes right here is where they meet. And then I do my up one, right one, up one, right one, up one, right one, and then up one, left one, up one, left one, up one. I'm kind of generous, should be right there, there, and there. Okay, and then I draw all the way off the graph. And there you go. All right, let's try one more. Except in this case, we're gonna do the opposites of those signs. So let's say we had y equals x minus 1 and then plus 4. All right, how do we do this one? So we got to find our vertex. Remember to go opposite of negative. So in that case, it's +1. And then 4 stays +4. So now we got 1 here, and then 1, 2, 3, 4. That is our point. And then, oh, I got no room. Up one, right one here, up one, left one here. Ah, it's gonna go like that. And that is the answers. Woohoo, we are done.